Hello students, I am Dr.A.K, Professor of Chemistry. Today I am going to discuss general characteristics of characteristics of the compounds of the alkali metals. Last class I have discussed chemical properties and uses of alkali metals. Now I am going to discuss general characteristics of the compounds of the alkali metals. All the common compounds of the alkali metals are generally ionic in nature. General characteristics of some of their compounds are discussed here. First, oxides and hydroxides of alkali metal. Oxides and hydroxides of alkali metal. On combustion in excess of air, lithium forms mainly the oxides, lithium oxide Li2O, plus some peroxide Li2O2, that is the peroxide. Sodium forms the peroxide Na2O2. Peroxide means between O and O single bond, and with each oxygen one sodium will be attached. Okay. And sodium also forms a superoxide like Na2O2. Here again I want to tell you, in superoxide or you can tell in all oxide, this metal have oxidation state +1. Okay, in superoxide also NaO2, then O2 has one negative and molecule is neutral, hence one negative means here sodium will be one positive. Then here sodium had +1 oxidation state or oxidation number. This type of question is asked. Always here molecule is neutral, then NaO2, then O2 is 1 minus, then obviously N will be 1 positive. Then all you can say metal, all metal in oxide form, maybe monoxide, maybe peroxide, maybe superoxide, in all type of oxide they have +1 oxidation state. While potassium, rubidium and cesium form the superoxide. This sodium forms the peroxide Na2O2 and some superoxide, but potassium, rubidium and cesium form the superoxides MO2. Under appropriate condition, pure compounds M2O, M2O3 and MO2 may be prepared. The increasing stability of the peroxide or superoxide as the size of the metal ion increases is due to stabilization of large anions by large cations through lattice energy effect. Again here you listen it. The increasing stability of the peroxide or superoxides as the size of the metal ion increases. Why they are stable, I am telling that things, is due to the stabilization of large anions by large cations through lattice energy effect. These oxides are easily hydrolyzed by water to form hydroxides according to the following reaction, means M2O plus H2O. It forms 2M plus 2OH minus. Here M is metal. Or you can say peroxide M2O2. M2O2, M is general, M presents a metal. M2O2 plus 2H2O. It forms a 2M plus, means metal ion, 2 metal ion, plus 2OH ion, plus peroxide H2O2. H2O2, this is important reaction. M2O2 plus 2H2O, it forms a 2M plus 2OH minus plus H2O2. And third reaction, MO2, superoxide, 2MO2 plus 2H2O. It forms 2M plus 2OH plus H2O2 plus O2. This is very important reaction, because here you are getting 4 products. Out of 4 products, 2 products are very important. Again you listen, 2MO2 superoxide, 2MO2 plus 2H2O. It gives 2M plus, means metal ion, plus 2OH minus plus H2O2 plus O2, means oxygen and peroxide both you are getting. Okay, this is a very important reaction. The oxides and the peroxides are colorless. The oxides and peroxides are colorless. Okay, when this will be in pure state, then oxides and peroxides are colorless when pure, but the superoxides are yellow. Question will be asked. Oxides, I told you oxides and peroxides are colorless, but the superoxides are yellow or orange in color. This you have to remember. Okay, oxides and superoxides are colorless when pure, but the superoxides and are yellow or orange in color. The superoxides are also paramagnetic. This is again important question. Question is asked. The superoxides are also paramagnetic. Sodium peroxide is widely used as an oxidizing agent in inorganic chemistry. Okay, sodium peroxide is widely used as an oxidizing agent. Okay, particularly in organic chemistry. Now one question is asked, why is KO2 paramagnetic? This question is asked, why KO2 is paramagnetic? Then explanation I am telling you. Actually KO2 is a superoxide. Last class I asked about what is the oxidation state of KO2? What is the oxidation state of K in KO2? Last class I have discussed oxidation state of KO2. Oxidation state of K in KO2. Then it was +1, because O2 has 1 minus, then obviously KO2 is neutral, hence K will be plus. Here question is, why is KO2 paramagnetic? Then same type of answer. The superoxide O2 1 minus is paramagnetic because of one unpaired electrons. Because of one unpaired electrons in anti-bonding pi 2p molecular orbital. Anti-bonding pi will be there, anti-bonding pi 2p molecular orbital is there, in that one electron is there, one unpaired electron. That's why KO2 is paramagnetic. Now other things I am going to tell you. About the hydroxide. The hydroxides which are obtained by the reaction of the oxides with water are all white crystalline solid. Okay. Hydroxides which are obtained by the reaction of the oxides with water are all white crystalline solid. The alkali metal hydroxides are the strongest of all bases, dissolves freely in water. Here again you listen. Alkali metal hydroxides. The alkali metal hydroxides are the strongest of all bases. Correct? Alkali metal hydroxides are the strongest of all bases. Base may be of different alkali also, different metals, but alkali metals are strongest of all bases and dissolves freely in water. Here one should understand difference between alkali and base. Base, actually all alkali will be soluble in water, but all bases are not soluble in water. That is the difference. Okay, alkali always will be soluble in water, but bases will not dissolve in water. Okay. Then here I told you that alkali metals hydroxides are the strongest of all bases and dissolve freely in water with evolution of much heat on account of intense hydration. Okay. This I have discussed about the oxides and hydroxides of alkali metal. Now I am going to discuss halides of alkali metals. Then here now listen, the alkali metal halides MX, M capital M capital X, M means metal, X means halogen like fluorine, chlorine, bromine, iodine. MX are popularly known as metal halide. Metal halides are all high melting points. The alkali metal halides are all high melting, colorless, crystalline solid. They can be prepared by the reaction of the appropriate oxides, hydroxides or carbonate with hydroxides with a hydrohalic acid, HX we can tell, hydrohalic acid in general, HX, capital H, capital X, like HCl, HBr, HI. Then in shortcut it is written as HX, capital H, small x. Then this metal halide can be prepared by the reaction of the appropriate oxides, hydroxide, carbonate with aqueous hydrohalic acid. All of these halides have high negative enthalpies. of formation, means HF will be negative value. For fluorides, this particularly here, this halides have high negative enthalpies of formation. Okay, the delta H value for fluorides becomes less negative. Okay, why? As we go down the group, delta H value for fluorides becomes less negative as we go down the group. Okay, while the reverse is true for delta H for chlorides, bromides and iodides. For a given metal, delta HF you can tell formation, delta HF you can tell, F means formation, always becomes less negative from fluorides to iodide. Bromide, I was talking about that, fluoride becomes less negative, fluorides, as we go down the group, means starting from lithium to cesium. Fluoride, its value will be, you can say, less as we go down the group, whilst the reverse is true for delta FH for chlorides, bromides and iodides. For a given metal, delta FH always becomes less negative from fluoride to iodide. Okay, for a particular metal, delta FH always becomes less negative from fluoride to iodide. The melting and boiling points always follow the trend. What are the trend? Then fluoride, melting point and I am talking about the melting point and boiling point of metal halide. Then the melting and boiling points always follow the trend, like fluoride is greater than chloride is greater than bromide, and bromide is greater than iodide. Okay, means melting point of fluoride, melting point and boiling point of fluorides are highest and iodides are lowest. Okay, then melting point and boiling point of fluorides are highest. Second position is for chlorides, third position is for bromide and last position is for iodide. All these halides are soluble in water. The low solubility of lithium fluoride has low solubility. The low solubility of lithium fluoride in water is due to the high lattice enthalpy, whereas the low solubility of cesium iodide is due to the smaller hydration enthalpy of its two ions. Okay, then here again you listen, the low solubility of lithium fluoride is less soluble in water. The low solubility of lithium fluoride in water is due to its high lattice enthalpy, whereas the low solubility of cesium iodide is also less soluble. Then this is due to the smaller hydration enthalpy of its two ions, cesium ions. Cgm ions like a CSI, it's a small this thing, its solubility is less in water, low solubility. This is due to the smaller hydration energy, means it will release less energy. When water molecules it will come in contact with the water molecules, then it will absorb. That time it will release less energy. Okay. Other halides of lithium are soluble in ethanol. Lithium, I am talking about. Lithium, others are not like this. Lithium, particularly lithium. Other halides of lithium are soluble in ethanol, acetone, and ethyl acetate. Lithium chloride is soluble in pyridine also. Okay, then this is exceptional things I am telling you. Other halide of lithium. Okay, other halides of lithium are soluble in ethanol, acetone, and ethyl acetate. Okay, lithium chloride is soluble in pyridine also. This is a special, you can say, question. It is asked. Now I am going to talk about the salts of oxoacids. Salts of oxoacids. Metal, alkali metal will, you can say alkali metals make salt, Then salts of alkali metals. Okay. But this is a special type of salts. Salts of oxoacid, OXO. Salts of oxoacids. Oxoacids are those in which the acidic proton is on a hydroxyl group. Here you have to just, I will give the example, but now should understand here. Oxoacids are those in which the acidic proton is on a hydroxyl group with an oxo group attached to the same atom. As for example, carbonic acid H2CO3. It is carbonic acid. Now you can see oxoacid. What is the attached? H2CO3. Then this is a carbonic acid with it OC and OH whole 2 is attached. Okay, this is the oxo group. OCOH whole 2. Then here I told you that an oxo group attached to the same atom. Then here that with H2CO3, now OCOH whole 2 group is attached. Now next example, sulfuric acid H2SO4. With this O2SOH whole 2 is attached. O2SOH whole 2. Okay, this actually is called oxo group. Now here you see this H2CO3 I am talking about, then OCOH whole 2. Then total number of oxygen is how many? OCOH whole 2. Then OH whole 2 means 2 hydrogen, 2 oxygen. And outside 1 carbon, 1 oxygen. Then here it became total same things, H2CO3, H2CO3. Okay, same things, H2CO3. Now you are writing the oxo form. Then here this is the OCOH whole 2. Then 2 hydrogen, 2 oxygen in the bracket, 1 oxygen outside, then 3 oxygen and 1 carbon, then H2CO3. Like that way sulfuric acid H2SO4. Here O2SOH whole 2. Means here total hydrogen is 2, this total hydrogen is 2 and total oxygen is 4. OH whole 2 means 2 oxygen, 2 hydrogen. Outside 2 oxygen is there, 1 sulfur is there. It became H2SO4. H2SO4. Then now this is actually oxo group. The alkali metal forms salts with all the oxo acids, or this simply also we can tell H2CO3 and H2SO4. This is the oxo acid because oxygen is there. Okay. Then here alkali metals form salts with all the oxo acids. Here importance has been given oxo acid where oxygen is there. Okay, because acids may be where oxygen is not there. As for example HCl, HBr, HI, HNO3. HNO3 oxygen is there, but HCl, HBr, HI oxygen is not there, but they are acid. Okay. Then here oxo means that type of acid where oxygen is there. The alkali metals form salts with all the oxo acids. They are generally soluble in water and thermally stable. Means metal salts are thermally stable. Means if you will heat it, it will not break so soon. And it is water soluble. They are carbonate, metal carbonate I am talking about. Metal carbonates in most cases the hydrocarbons here this salts are generally soluble in water and thermally stable. They are carbonates, and in most cases the hydrocarbonate, bicarbonate, hydrocarbonates are also known as bicarbonate, then carbonate, and in most cases the hydrocarbonate are highly soluble in highly stable to heat. It will not break. Carbonates are very, very stable. Bicarbonates are also stable. Means if you will heat it, it will not break. That is the example. Marble you have seen, it is very strong. Marble, calcium carbonate, or particularly there this carbonate and bicarbonate, they are strong. They are carbonate, and in most cases the hydrocarbonates are highly stable to heat. By heating there will be no effect. As the electropositive character increases down the group, again you know that in a group it will go down. As the electropositive character increases down the group, the stability of the carbonate and hydrocarbonates, okay, hydrogen carbonate, that is a bicarbonate. As the electropositive character increases down the group, the stability of carbonate and hydrogen carbonate increases. This also increases. Electropositive character increases down the group, you know. The stability of carbonate and hydrogen carbonate also increases. Lithium carbonate is not so stable to heat. Lithium, being very small in size, polarizes a large carbonate ion, leading to the formation of more stable lithium oxide and carbon dioxide. Okay. Lithium carbonate is not so stable to heat. Lithium, being very small in size, polarizes a large carbonate ion, leading to the formation of more stable lithium oxide and carbon dioxide. Finally, it will form lithium carbonate. Finally, it will form after heating lithium oxide and carbon dioxide. Its hydrogen carbonate does not exist as a solid. Okay. Lithium bicarbonate I am talking about. Its hydrogen carbonate does not exist as a solid. Okay. This I have told about the salts of this things, alkali metal, salts of alkali metals. Okay. And how this reacts, actually know that salts, metal will form salts with acid. Then here I discuss about the oxoacids. Okay. Now I am going to discuss the anomalous properties of lithium. Very, very important, most important. Okay. Here two things they will ask, two types of questions they will ask. Anomalous properties of lithium. Here one question they will ask, that will depends upon the difference between lithium and other alkali metals. What are the difference between lithium and other alkali metals? Okay, question will be asked on the basis of this difference. Okay, and other type of question will be asked similarities between lithium and magnesium. Okay, then I will discuss for both. Then now I am discussing anomalous properties of lithium. The anomalous behavior of lithium is due to the first, exceptionally small size of its atom and ion, and second, high polarizing power, that is the charge upon radius ratio. Charge upon radius, charge divided by radius ratio. Okay, that is called charge radius ratio. Okay, high polarization power means that only charge divided by radius. That is also called ionic potential. That is also called ionic potential. High polarizing power. Then these are the two regions. First, exceptionally small size of its atom and ion, and second, high polarizing power, that is the charge upon radius ratio. As a result, there is a increased covalent character of lithium compounds, which is responsible for their solubility in organic solvent, or because they are making now covalent bond. Lithium is forming covalent compound, then covalent bonds are soluble in organic solvents. Further, lithium shows diagonal relationship to magnesium, which has been which I will discuss. Okay, But here now just I want to tell difference between lithium and other alkali metals. What are the differences? Then first I am talking about there are 6-7 differences. I will tell one by one. First differences, lithium is much harder. Lithium is much harder. Its melting point and boiling point are higher than the other alkali metals. Okay, I am telling you, give priority for lithium. Okay, you can't simply ignore it, and you can't take it as a other metals of first group. You have to give a special attention. Then first I told you lithium is much harder. Its melting point and boiling points are higher than the other alkali metals. First point. Second, lithium is least reactive. See, despite its reduction potential is a minus 4.03, very high negative value. Okay, it means lithium should have been very reactive according to this value. High negative value, lithium should be or should have been shown very high reactive value, but it is not like this. Lithium is least reactive, but the strongest reducing agent. Means it's you know that reduction potential value is very high, but reaction wise it should be actually also, it should have shown, but it is not showing reactivity like that way. Lithium is least reactive, but the strongest reducing agent among all the alkali metals. On combustion in air, it forms mainly monoxide Li2O and nitride Li3N. Unlike other alkali metals, other alkali metals will not form Li3N. Okay. Then this is important things. On combustion in air, it forms mainly monoxide lithium Li2O and nitride Li3N, unlike other alkali metals. Here one thing I want to tell you that about the reactivity of lithium, it is least, because now despite it should have shown very high reactivity, but it is not very least because of these things, hydration energy. It will absorb water molecules. Then water molecules will be covered everywhere with lithium. Then how will lithium react? Hydration energy means H2O, lithium 2H2 have seen. Then lithium everywhere with lithium water molecules will be there. Then it will not get chance to react with others. Okay, this is actually a reason. But in electrolysis, when it will function as a electrode, then that time H2O will be not there, and with water actually it reacts violently this lithium. That's why this in a non-aqueous solution, non-aqueous solvent is required for the lithium, because water, it will react with the water. Okay, and reaction is there only with water. Now first any solution will be there, then it will be in aqueous solution only. Then first it will react with water only, and violently it will react. That's why non-aqueous solvent is required for the lithium reaction. Then now here I told you the lithium is least reactive, but the strongest reducing agent, because it has most tendency to lose the electron. Third, you can see, different properties. Lithium chloride is a deliquescent and crystallizes as a hydrate, LiCl2H2O, whereas other alkali metal chlorides do not form hydrates. See, difference is here only LiCl2H2O. Lithium chloride is forming, whereas the other alkali metal chloride do not form hydrates. Now next, fourth different point. Lithium hydrogen carbonate is not obtained in the solid form. Okay, you will not get in the solid form. Lithium hydrogen carbonate, that is a lithium bicarbonate, Bi. Bi means 2. Lithium hydrogen carbonate, that is also called lithium bicarbonate, is not obtained in the solid form, while other elements form solid hydrogen carbonate. Other metal will form solid bicarbonate. Next point, that is the fifth point. Lithium unlike other alkali metals forms no ethanide. It will not form no ethanide, no reaction with ethine. It will not react with you can say ethine. Okay, it will not form ethanide. It will not form. Lithium ethanide is not formed. Ethanide on reaction with ethine. Ethine means ethane, single bond, ethylene, double bond, ethine, triple bond. Keep in mind, carbon, if a single bond is there, CH3, between the two CH3, one single bond is there, then it is ethane, ANE last, and double bond, CH2, in the middle double bond is there, then that is a ethene, ENE means double bond, and like that way CH and carbon triple bond, then it is called ethine, acetylene gas, if HH is there. In organic compound, when I start, I will tell you. Then now I told about the these things. Lithium, different between lithium and other alkali metals, difference. Now 2 more points I want to tell you. That is point 6. Lithium nitrate when heated gives lithium oxide, whereas other alkali metal nitrate decomposes to give the corresponding nitrite. Okay, lithium nitrate when heated gives lithium oxide. Lithium nitrate gives lithium oxide, whereas other alkali metal nitrates decomposes to give the corresponding nitrite. Means nitrate will give nitrite. For other metals will give nitrite, but lithium will give oxide. Then lithium nitrate reaction you can write LiNO3. Balanced equation I am telling you. 4LiNO3. On heating it will decompose and it will give 2Li2O. 2Li2O, lithium oxide, Li2O. 2Li2O plus 4NO2, nitrogen gas. Its color is brown color, plus oxygen. This reaction is very important due to 2 reasons. First, exceptional with other group metals. Lithium nitrate is giving lithium oxide, that is the first things. And one important thing, it is giving 2 gases at a time. brown gas, that is a NO2 gas plus oxygen gas. Okay, then 4LiNO3, it gives 2Li2O plus 4NO2 plus O2. But other will give 2NaNO3 is there, sodium nitrate, then it will give NaNO2, nitrite. NO3 is nitrate, NO3 is nitrate and NO2 is nitrite. Okay, don't forget. Then 2NaNO3 on heating, on decomposition, it will give sodium nitrate will give sodium nitrite plus oxygen. Okay, and one more different point I am telling you, 7th point, lithium fluoride and lithium oxides are comparatively much less soluble in water than the corresponding compounds of other alkali metals. This is the, you can say, important points I am telling you. Okay, lithium fluoride and lithium oxides are comparatively much less soluble in water than the corresponding compounds of other alkali metals. Now I told the differences. These 7 differences I told you. Okay, 7 points of differences. Now I am going to tell points of similarities between lithium and magnesium. Okay, now that is what we are telling, that diagonal relationship. Okay, lithium shows a diagonal relationship with magnesium. Then that I am going to tell you points of similarities between lithium and magnesium. Okay, what are the, you can say, these things, points of similarities, and they have a diagonal relationship. No? Then what are the similarities? That I am going to tell you. Here also 5-6 points are there, I will tell you. Okay, then here the similarities between lithium and magnesium is particularly striking and arises because of their similar sizes. Magnesium and lithium have similar sizes. As for example, atomic radii. Lithium has 152 picometer. Lithium atomic radii means radius. Atomic radius is 152 picometer, and magnesium 160 picometer, roughly very close. And ionic radii, then lithium is 76 picometer and magnesium has 72 picometer, very close. 1 picometer means 10 to the power minus 12 meter. 10 to the power minus 12 meter is called picometer. Then I told about the radius, atomic radius and ionic radius. Radius of atom, that is called atomic radius, when you have not removed the electron. But when you will remove the electron, when the electron will be removed, then that time it will form ion, then size will decrease, then that time it will in the cation form, then it is called ionic radius that time. Now just come to the point of similarities. Both lithium and magnesium are harder and lighter than other elements in the respective group. One group is of lithium, alkali metal, and magnesium is in alkaline earth metal. Group 1, group 2. Okay, then magnesium is from group 2, lithium is from group 1. Then now you can see the similarities. Then first point I told you, both lithium and magnesium are harder and lighter than other elements in the respective groups. Lithium and magnesium react slowly with water. Their oxides and hydroxides much less soluble, and their hydroxides decomposes on heating. Both form nitride Li3N and Mg3N2. This question is very very important. Okay, both form nitride. Lithium will form lithium nitride, magnesium will form magnesium nitride, but by direct combination with nitrogen. Okay, this is the second similarity. Again I am telling you, second similarity. Lithium and magnesium react slowly with water. Their oxides and hydroxides are much less soluble, and their hydroxides decomposes on heating. Okay, and already this point I already told you, and also I told now both form a nitride, lithium nitride. Lithium will form lithium nitride and magnesium will form magnesium nitride by direct combination with nitrogen. Third point, you can say similarity. The oxides of lithium, means lithium oxide and magnesium oxide, do not combine with excess oxygen to give any superoxide. Both will not give superoxide. Okay. Now next similarity, fourth. The carbonate of lithium and magnesium decomposes easily on heating to form oxides and carbon dioxide gas. The carbonate of lithium and magnesium decomposes easily on heating to form the oxides and carbon dioxide gas. Solid hydrogen carbonate means bicarbonate. Solid hydrogen carbonate are not formed by lithium and magnesium. Other they will form, but lithium and magnesium will not form bicarbonate. Okay, solid I am talking about. Solid hydrogen bicarbonate. So also you can tell solid hydrogen carbonate are not formed by lithium and magnesium. Next similarity, that is the fifth. Both LiCl and MgCl2 are soluble in ethanol. Okay, both are soluble in ethanol. You know that this lithium forms covalent bond. Okay, both lithium chloride and magnesium chloride are soluble in ethanol. Due to this they form a covalent compound. Okay, then due to that covalent character they are soluble in ethanol. And last point, that is the seventh and sixth point, both LiCl and MgCl2 are deliquescent and crystallizes from aqueous solution. Okay, both LiCl and MgCl2 already I discussed. Both LiCl and MgCl2 are deliquescent and crystallize from aqueous solution as hydrates. Lithium chloride twice H2O and magnesium chloride 8 H2O. MgCl2 H2O. This I told you about the, you can say, similarities between lithium and magnesium. Okay, and now some compounds are there. Some compounds of these things, sodium I will discuss in the last class. Okay, there some compounds are there, compounds of sodium special focus, because question is asked, then I will discuss separately. Okay, today I am stopping only here. Thank you.